Good morning, class. Here's elementary statistics practice test number 5, covering chapters 10, 11, and 12. Chapter 10, correlation and regression. Chapter 11, goodness of fit. And contingency tables. Chapter 12, analysis of variance. And here we are going to cover chapter 10, correlation and regression. Again, as usual, here's a pledge on my honor that I will neither give nor receive unauthorized assistance. You may use formula sheet, tables, and a graphing calculator for statistics. Let's get started. Here's module 5, chapter 10, correlation and regression. Given the sample data, here's the x values, here's the y values. Find the value of the linear correlation coefficient R. Test the claim that there is a linear correlation between the two variables x and y. Use both A, method 1, and B, method 2, with alpha 0.05. Find the regression equation. Find the best predicted value of y when x is equal to 2. So, first and foremost, what is a scatter plot? What is the linear correlation, and so forth? A scatter plot is a graph of the ordered pairs x and y. X, as usual, is the independent variable, and y, the dependent variable. So when we plot those pairs, which is called, the result is called a scatter plot, what happens? Either they look like that with sort of a linear relationship with a positive correlation, distinct straight line or linear pattern. We say that there is a positive linear correlation, positive slope, rise over run. That's the definition of a slope. Positive linear correlation between x and y, since as the x value increases, the corresponding y values also increase. If there is a strong positive linear relationship between the variables, the value of r will be close to positive 1. 0.7 or larger is considered a strong positive linear relationship. Or it may look like that with a negative slope, so negative correlation. Distinct straight line or linear pattern, we say that there is a negative linear correlation between x and y, since as the x value increases, the corresponding y values decrease. If there is a strong negative linear relationship between the variables, the value of r will be close to negative 1. So negative 0.7 or smaller, between negative 0.7 and negative 1. Or it may be all over the map. There is no correlation. So no distinct pattern, which suggests that there is no correlation between x and y. More specifically, there is no linear correlation. So 0 means no linear correlation. As we move to the right, there is some linear correlation from this number, which is about 0.7 to +1, strong positive linear correlation. Over here, we have some correlation, and from negative 0.7 to negative 1, strong negative linear correlation. Correlation does not imply causality. Just because two things happen at the same time or seem related doesn't mean that one causes the other. And R, the correlation value, is always between negative 1 and positive 1. Can it be equal to negative 1? Can it be equal to positive 1? Absolutely. Positive 1, perfect linear correlation. On the positive side, negative 1, perfect linear correlation on the negative side. For example, ice cream sales and drowning incidents both increase in summer. Correlation, these two trends go up together. No causation. Ice cream doesn't cause drowning. Instead, a third factor, hot weather, leads to both. So it's important to understand the concept of correlation versus causation. What causes it to happen? All right. Now we are going to actually do the job we started looking at the question. So the same um, data that was given, we want to find the value of linear correlation. Nobody expects you to do this by hand. But I want to show you how it's done if we were to do it by hand. Or is n summation of x y minus summation of x times summation of y over the square root of n summation of x squared minus summation of x quantity squared times the bracket n summation of y squared minus summation of y quantity squared. As you can see, it's pretty involved. So what do? We are going to write the x and y in either a row or column, makes no difference. First of all, we have 1, 2, 3, 4 pieces of data. N equals 4. Secondly, here's the x, here's the y. So 1, 1, 3, 5, 2, 8, 6, 4. Since as we look at this, we need x times y, we need the x squared, we need y squared. So this column, we call it x times y. So 1 times 2 goes here, 2. 1 times 8, 8. 3 times 6, 18. 5 times 4 is 20. X squared. 1 is 1, 1 is 1, 3 becomes 9, 5 becomes 25. Y squared, 2 becomes 4, 8 becomes 64, 6 becomes 36, 4 becomes 16. So that's the first column, second column, third column. And as you can see, these are all summations. We need summation of x. We add those 1 plus 1 plus 3 plus 5. Then we add those 2 plus 8 plus 6 plus 8, and the rest of them as follows. So as you can see, the bottom row consists of summation of this column, called summation of x, summation of this column, summation of y, summation of xy, summation of x squared, summation of y squared. So now we're going to put this into this formula. So n times summation of xy, n times this number, 48, minus summation of x, summation of 10, minus 10 times 20, over. Then you put the square root, n is 4. Summation of x squared, so put this number, minus summation of x, 10, quantity squared. This one, n is 4 again. Summation of y squared, 120, minus summation of y, 20, quantity squared. So take a look. This is how you do the math. Minus 8 over the square root of 44 times 80, and we get negative 0.135. So again, on purpose, I chose a very small set of data, so I wanted to show you how it's done by hand. Okay, it is doable. However, nobody expects you to do it by hand, especially if it happened to be more than that number. So as far as graphing calculator, we will put x in one and y in another list, L1 and L2. So stat, edit, clear list L1, or highlight and clear, type in your data in L1, and we're going to do L2 as well. So L1 and L2 are filled up with x and y. Then we do linear regression t-test. It gives us a lot of information. For now, we are interested in one of them. So stat test, linear regression t-test, enter L1 and L2, and choose not equal, and always choose not equal. And you'll see when we do the test of hypothesis. All right, L1 and L2 not equal, calculate. And you see this one, you see the down arrow, that means there is more. And there's a lot of stuff here. For this piece, we are only interested in R. Notice. Now, if I stop at 4, next one is 8, goes down, goes up to 5. Okay, that's how you do that. It's pretty straightforward. I hope everybody is okay with that. Again, I wanted you to see the calculation by hand in case. It's really not that bad. It's just tedious. It takes some time to do so. Nobody expects you to do this by hand, as it was mentioned. Now, part B, we are looking at the same question. We are going to test the claim that there is a linear correlation between the two variables x and y, and we're going to use two methods. And what do we start with? H0 rho. By the way, R is the linear correlation for a sample, rho for the population. and H0 row is 0, H1 row is not 0, which makes it a two-tailed test, and that's a claim. So we are testing to see if there is a linear correlation. Okay, so this is the claim. If rho is not equal to 0, then there is a correlation. So having said that, we have to go with test statistic, the next part. And again, we're going to look at two methods. With method one, test statistic has this formula. And as always, I want you to know this comes from here, and mu sub r equals rho. Okay, so you know. So that's always coming from H0, which is 0. The rest, we're going to plug in. This is the information from the previous page. We have the N, we have the R, plug in. In other words, R is this number, and N is this number. Plug in. Okay. So test statistic R is square root of N minus 2 over 1 minus R squared. By the way, I want you to look at this formula, and I hope you recognize mathematically, algebraically, these two are identical. Again, when you ignore that, and we ignore it because it's 0. So these two formulas, depending upon the text, are identical. They always use 0 for this one. And degrees of freedom is N minus 2 because we have two groups. And having said that, let's plug in, evaluate it, and we end up with test statistic. T is negative 0.1927. Now for method 2, the value of test statistic R is the value of test statistic. Now we want to find CV, critical value. We want to find RR, rejection region. We want to find NRR, non-rejection region. That's what we do always. So alpha is 0.05. Degrees of freedom is N minus 2. 4 minus 2 equals 2. And critical value from the table or technology results in the following. We should always do the drawing, of course. Over here, N is 4, alpha is 0.05. Use R equals critical value from Pearson correlation coefficient table. So there is a table that we are going to use, and I'm going to go over that in a moment. The next page, I will show you the table. So T has a table, Z has a table, chi-square has a table, and Pearson correlation coefficient also has a table. So from the table, we get plus minus 0.950. Y plus minus, again, it's a two-tailed test. So if we do the drawing with the t-test, okay, notice critical value is negative and positive 4.303. The test statistic negative 1.927 is way into the non-rejection region, failed to reject H0. Whereas here is the same thing. As you can see, rho, okay, is negative 0.950, R is negative 0.950 and positive 0.950, whereas the test statistic negative 0.135 is in between. In between is a non-rejection region. So fail to reject H0 in both cases. What does it mean? If you're not rejecting H0, you're rejecting H1, the claim becomes false. What does it mean? There is no linear correlation between the two variables. This means no linear correlation. This means there is a linear correlation. So, as you recall in the previous page, we went through the process, okay, and when we put L1 and L2 and we ran linear regression t-test, there were a couple of pages. One page has this one. If you look at this page, again, this has been run in the previous page, you can see this number, test statistic that we have here, of course. Why is this different? Because if you look at this, for R, they have chosen to go with many, many, many more decimals. That's the reason. The other thing is that degrees of freedom is 2, as you can see. Okay. degrees of freedom is 2. And what is this one? This is the p-value, which is 0.865 and clearly larger than alpha of 0.05. And same decision, do not reject H0 or fail to reject H0. Very straightforward. I hope everybody is okay with that. And we're going to take it from there. So having said that, let's look at a couple of issues here. There was not enough room in the previous page. Remember, method 1 used the t-test alpha was 0.05 and degrees of freedom of n minus 2 equals 2. First, in the left column, you locate 2. Then over here, area in one tail. No, we need the area in two tails. And that would be 0.05. Okay, 0.05 because alpha was 0.05, right? And when you put them together, the answer is this one. So you call the critical value the same number with the plus minus t's plus minus 0.4303. How does this guy work? Well, n is 4. So in the left column, you choose n equals 4. And in the top row, you choose alpha of 0.05. When you put them together, the answer is 0.950. And now your claim critical value is plus minus 0.950 because it was a two-tailed test. So it's pretty straightforward. Continuing with the same question, the regression equation. Use the formulas for various parts. Y hat is B0 plus B1x or Y hat is A plus BX. I'm going to show you both because depending upon the text, okay, they may use this one or this one, and the graphing calculator uses this one. B1 is n summation of xy minus summation of x summation of 1 n over n summation of x squared minus summation of x quantity squared, similar to R. And y-intercept b sub 0, in this case, b sub 0 or A. Remember, I want to remind you, y equals mx plus b. This is the slope, right, everybody? And this is the y-intercept. Okay, so look at this one. This is the y-intercept. And this, my apologies, let me just, this, okay, let me. This one is the slope. This one is the y-intercept. So just reminding you of what we learned in basic algebra. And also let me erase the work and continue with the thoughts that y-intercept is equal to y bar minus b1 x bar. Y bar is summation of y over n, x bar is summation of x. Okay. And I'm reminding you what we got already. So this has been already calculated. Again, I want to show you with hand. So we put n, which is 4, summation of xy, which is 48, minus summation of x, summation of y, 10 times 20, over n summation of x squared times 36, minus summation of x quantity squared, and you work it out and you get this number. So we have one of them. Now, in order to get to the next one, you have to find the average y and average x. So you add them up. So we already know summation of x is 10, summation of y is 20, and each one we divide by n, which is 4. So this becomes 5, this becomes 2.5. We already have those. We have to add them up, but it's already there. So now we're going to use this formula. V sub what is y bar minus b1x bar. So this is 5 minus this number, which is this one. And now you definitely want to use a lot more decimals times x bar. Notice using a lot more decimals. And we get this number. So according to the formula, y bar is negative 0.182x plus 5.455. And notice y equals a plus bx, the same formula. Further notice a and b. Here's a, 5.4545, this one. And here's b, negative 0.181818, so 0.18 if you stop here, 2x. So it does it for you. You need to understand that, I mean, this is something you do not do by hand, but concept should be pretty straightforward. Okay, find the best predicted value of y when x is equal to 2. Here's very important to understand. No significant linear correlation. This is what we did. We came up with. The best predicted value for y is always y bar in that case. R was negative 0.135, so y bar is the answer 5. Okay. If not, then you plug in. Let's say there was a correlation, then you plug in the x value. Having said that, again, as far as the p-value is concerned, larger than alpha 0.05, fail to reject H0 or don't reject H0, no linear correlation. A researcher is studying the effects of testosterone injection on different lab mice. She controls the concentration of testosterone injected into the mice and measures their metabolic rates. Analyze the following data set. Here's the data set. Will you be running a correlation or regression? First and foremost, testosterone X and the metabolic rate Y. Find the value of the linear correlation coefficient R and test the claim that there is a linear correlation between the two variables X and Y. We are choosing to do that. Definitely, we have to run a regression. So the answer is regression since she controls the concentration of testosterone injected into the mice and measures their metabolic rates. Then definitely that's what we run, which means the first part, H0, rho equals 0. HA, I've mentioned it before, either H1 or HA, rho is not equal to 0, which makes it a two-tailed test always. Now, notice if rho is 0, what it means. There is no correlation between the concentration of testosterone in mice and their metabolic rates. However, if there is a correlation between the concentration of testosterone in mice and their metabolic rates, and then we get to rho not being 0. So we run the Excel, or you can use TI calculator. Remember, L1 and L2 makes no difference. It gives you the table. I'm going to go over the meaning of a table step by step. So you don't have to do this by hand. So according to Excel, R is 0.9934 and R squared is 0.9869. So those are the values that we get from Excel. And then we have these coefficients, standard errors, T stat, P values. So we're going to figure out what they are. But this is according to technology. Now we are going to go through the process and make some sense out of what we got. So I'm going to put the table here. N is 17, okay? Excel says R is this, R squared is this, and we wrote H0 and HA or H1. So we're going to start with test statistic. As you recall, this is from the formula sheet. You don't have to do much because this is given. So we're going to write from the technology 33.635. And based on the t-test, the p-value, look at the p-value, okay, is the area to the right of 33.6. So 33.6, you can't even locate that. It's way off. Remember, from -3 to +3, it covers almost everything, 99.7%. So 33 somewhere here. The area to the right of that is practically nothing, which is this number. This number. Area to the right of, I can't even locate that, okay? It's way into the right side, way into the rejection region. 1.5316 times 10 to the power of -5, e minus 15. That means this decimal, okay, start counting 1, 2, 3, 4, all the way to 15 and put a decimal. So practically it is 0, okay? For method 2, R is the choice for the test statistic. We found it to be this number, 0.9934. N is 17, alpha is 0.05. And from the Pearson table, we get plus minus 0.456. And this is negative 0.456. This is positive 0.456. This is way into the rejection region, much larger than 0.456. Same decision, reject H0 or fail to reject H0, since now the p-value 1.5316 times 10 to the power minus 5 is less than alpha of 0.05. By the way, alpha is always chosen as 0.05 in basic research like that, even if they don't mention it, which makes the claim true. Remember, when you're rejecting H0, you're not rejecting HA. That is the claim, and it becomes true, which means there is a significant linear correlation between the two variables. Therefore, we conclude that there is a significant correlation between the concentration of testosterone and in mice and their metabolic rates. Since this is a regression study, the significant slope suggests that the increase in concentration of testosterone in mice causes increase in their metabolic rates. So we're going to continue on that thoughts. Significant slope. This is the slope for testosterone. Okay, significant, fairly large. I'm going to continue, same question, same information, and for part B, find the regression equation. The regression equation is given to you in essence. So according to this, y hat, this is the slope, okay? These are the coefficients, just those numbers. 199.05, 9, and we stop there, plus x plus 379.4928, we stop there, becomes 493. And again, reminding you of the formulas for that. Again, this is, you should be familiar with Excel to recognize those numbers as well. Find the best predicted value of Y metabolic rates when X is equal to 1.3, the concentration of testosterone. Now, we know that there is a significant linear correlation, therefore we plug in. What do we plug in? We plug in 1.3 here. So the answer will be 638.2697 accordingly. Using the above pairs and the value of R, what proportion of the variation in metabolic rates can be explained by the variation in the concentration of testosterone? Accordingly, R squared, let me explain that. The coefficient of determination, the proportion of the variation in Y that can be explained by the variation in X is given by R squared, and this is the number, or 98.69%. You don't have to do any calculation, but you need to understand the concept, everybody.